Okay, everybody, welcome. Happy GHO, I guess. A lot of activity going on. Let me get this out of the way first. No labs this week, so labs are not mandatory tomorrow. Why? You know, we have 3 separate labs. I want to keep the labs in sync, and the 10 to 12 lab is canceled. That being said, I will be in the labs. I will be in the 8 a.m. lab. I'll be there during the 10 o'clock slot, and I'll be there at the 4 o'clock slot. If you do want to come by, you can tackle homework 7. Homework 7, which is on functions, will be graded at 11 p.m. on Thursday. If you are present in lab 7 or you are in the 10 a.m. session, let me know. I will open up lab 7 if you did not finish it. Okay? If you do come to lab, we can also work on assignment 7. Reminder, it's a long weekend and we have Monday off, and assignment 7 will be due on the following Thursday. So if you want to come to lab, we can use that time to work on assignment 7, or you have plenty of time to do it over the break or into next week. Right? Friday, we will be having class as usual. Again, I do want to be respectful that people might want to take care of whatever you're doing for GHO. So hopefully this lecture will be recorded. I'd appreciate it if you're here, but if you're not here, I'll make the recording available and you can catch up later. 1 week from today, we will be having a quiz on chapter 7, which is functions. So make sure you're up to speed on the homework, the labs, the assignment by then. All right. So we are going to pick up today, again, on functions. Fingers crossed, we're going to close out the functions chapter today. We talked about this last time before the exam, the args and quargs. I'm going to go through that again because we rushed it a little bit, and then we'll look at these other sections today. So just as a recap, by this point, we should all know what a function is, what a function definition looks like. So I've shown this many, many times. We left off last time talking about these 2 parameters, the args and the quargs, which look a little bit different than the other ones. Args has that little star thing, and quargs actually has 2 stars on it. Anybody who knows C++, don't worry, this isn't pointers, but it is Python syntax or something special. All right, so let's jump into it. If you want to code along, this is an assignment 7, which you can get to in Blackboard, or you can get it straight up inside EdStep. All right, so remember when we have a print function, print seems to take an arbitrary number of variables, right? Or parameters. I could say print, and I can put variable A, B, C, D. They could be strings, they could be integers, they could be whatever. So let's create our own print function called myPrint that takes an arbitrary number of parameters. So what does that look like? Def, my function name. Now, when I want an arbitrary number of parameters, I say star args. I don't have to use the word args. I can use whatever I want there. It's just important that I have that star. But this is kind of the syntax we're used to seeing, or the convention is args. So put my colon, and then I have an indentation here, right? So if I want to print stuff that's in here, can anybody tell me what the args data structure is? Anybody who maybe knows Java, what you get when you pass in your main function, what you get? Yeah, when you have like public static void main in Java.
Oh, yeah.
You get a list. In Java, they use the term array, but this is really a list, right? So if I want to write my own print function here, right, I could just do a loop. This is sort of a lazy thing to do. I could say for item in args, right? and then I can say print item, and I'm going to delimit those with a comma if I wanted to. Right? Create your own print function, takes an arbitrary number, each delimited by a comma. Remember, the actual print statement itself does it by a space, right? So let me just give myself a little new line here, and then we'll call our function. I underscore print, and I'll pass in A, pass in B, see what that does. So A, B, comma, right? I pass in C, A, B, C, and then because Python is a dynamically typed language, I can put in other data types, right? I can put integers there, I can put floats, right? So this is kind of a naive way to do it. Not a perfect solution. You'll see there's that hanging, comma at the end here, right? So that's kind of a problem. I'm going to show you something that several of us have worked on, and pardon if this got flagged as AI. I do appreciate people, trying new stuff, but you have to understand what some of this new stuff is. So what I'm about to show you is something called a generator expression. It's not something we're going to teach in the intro course. If you want to use it, if you find it helpful in the course, feel free to use it, but please understand what it is, because it is kind of, you're bringing a bazooka to a knife fight, right? It's kind of a big deal. So I can actually do this. I can say print, comma, dot, join. Well, we all know what that means, right? Here, I can say, take this item thing. Where does item come in? You'll notice I don't have it declared anywhere in my function here, right? But I can say for item in args, okay? So if I run that up, I actually get the ideal solution. I don't get that comma. Now, I'm almost intentionally going through that very, very quickly because I'm not teaching this in this course. But this is called, I think they call it Pythonic method. It's the way Python does a lot of stuff. So this is basically saying, construct a list, right? It's a list generator that says, for item in args. We should be familiar with that syntax. But when you traditionally would have a for loop, and you're just doing like one thing, here, I'm putting it to the left of that for statement. So anybody who wants to talk more about this after class, I'm happy to do so. You can do something similar with branches and if statements. It is actually quite elegant. It is actually quite interesting and good to use. But it's one of those things that's very Python-centric. And our mission here is to learn like core computer science functions. You're not really going to see something like that in other languages, per se. All right, so let's move on in this problem set. Next example. Enhance my print so we take a delimiter, right? So I want to basically take that same function, but I don't want to just hard code the fact that I'm printing a comma. So I'm going to take that same function I have here, my print, but this time I'm going to add a different parameter called delimiter. And then in here, I'm going to do what we already know to do. I'm going to put a format string. So whatever I pass in there will be used, right? So here, now we'll take this, and let's put maybe a $sign. So I'll take a $sign, and then I'll put an arbitrary number of parameters, A, B, C. Okay. So when I run that up, oops, let's see what we did wrong here. Where'd that AF come from? Oh, because I have okay. A, F delimiter. That doesn't look right. Let's Be a little smarter here. Let's take that Groovy generator function we did here. Doing that stuff. Let's just take this. Let's put our delimiter there. A $, B $, C. If I want to make that delimiter 3 plus signs, I can add that in there, then I get those delimiters. So notice though, there's a little bit of magic here. This looks a little confusing because how do I know that parameter is delimiter and that parameter is the args, right? Any named parameter has to come before args. Okay. Again, with all this good stuff, the solution is here. So you can go back and look at this. I strongly suggest you do. It's also probably helpful for like the exams and stuff. I saw some people struggling yesterday with fundamentals like dictionaries. You know, you can always go back to the old lectures here, the old assignments, and look up how we create dictionaries, how we create lists, and all that good stuff. Okay, that next topic, kwargs, K-W-A-R-G-S, right? Create a function print map that takes just kwargs. Print out a message like this. My map has 7 keys and 7 values. So, and sorry folks, I am sort of assuming that you are keeping up with the homework and you already know what some of this is. My intent here is not to introduce this for the first time, but just to show you how we can use this good stuff. So when I have kwargs, kwargs basically have key values. They take a dictionary instead of just arbitrary parameters here, right? So this thing, like I mentioned, is kind of a dictionary. So if it's a dictionary, then I should be able to say for key comma value in whatever my dictionary is, in this case it's kwargs, dot items. Now I should be able to print, I can just use old school print here, KD, right? Now the difference between args and kwargs is when I call this function, I have to give it keys and values, right? So here, I'm going to want to say something like key 1 equals value 1. And then I want to say key 2 equals value 2. Now, there are some rules with what goes in here. These have to be an immutable data type. So normally we would do a string or something like that. Notice there's no quotes, right? That looks a little bit uncomfortable, but there's no quotes here. So, and then I guess, finally I can do key 3 equals, and I'll give it an integer. All right, so when I run up that code, this function gets called up here, right? And it prints out k comma v. Well, what's k? K is my key, v is my value, right? Okay. So again, just like that Taco Town thing I was happy with, very proud of myself though, be too proud of myself. We're just building on top of stuff here, right? So enhance what we did in 3 to take a message argument. All right, cool. So let's take this same function here. Print, let's put some message in here. Message. And maybe I'll print out here, print formatted string message. Our favorite message, hello world. So now let's run that up. Printed my message, and then it did the same thing it did before. It printed out that dictionary, right? There's a couple of pretty good examples in Zybooks talking about why you might want to do that, right? You might be writing a program that is asking a user for a whole bunch of arbitrary information, like information about themselves, their name, their address. Maybe people kind of know more information about themselves than other people do. So maybe they have a home address and a school address, and they want to put in like kind of arbitrary values. That's sort of the value of the Quarks stuff. All right. So let's move it on down here. Part 5. So building on top of all that, the name parameters, quargs, and args. And that's what you did in 4. Take a message, an args, and a quargs. So I have message. Here I'm going to take args. There I'm going to take quargs, right? So here I'm printing out my quargs. Remember, where quargs is a dictionary, args is a list, right? So here, I'm just going to have one thing, right? So maybe I'll do from args. I'll put my item. Uh-oh, unterminated triple quote, line 94. Attribute error. No thing called items. Oops. It's a list. List doesn't have something called items. It's just a list. So here I have my hello world. And let's see. There's no args. But interesting, it printed those quarks. Why? Well, when we look at the way we called our function, right, Python was pretty smart. And Python said, hey, I recognize that you only gave me key values. You gave me quarks. You didn't give me any args. You didn't give me any arbitrary lists of items, right? So unless I put them in here, like A, B, C, nothing's going to print. So now when we run that up, we get our message, print message. From args, we have our args, A, B, C. And then from quarks, we have P1, P2, P3. So pretty powerful stuff. We'll give you some chances to play with that a little bit. I think this is very difficult to memorize. You kind of have to just practice. You just have to try to print out, create different functions with different signatures. Okay. So that satisfies args and quarks. Now we're going to look at multiple function outputs. Yes, sir. I'll unhide it after lecture. Thanks for that. That's an oversight. They're probably all hidden in this, maybe? Yeah. Yeah. Okay. I'll unhide them after the lecture. Thanks for that. Okay. My friends who know other programming languages, you're probably comfortable with the fact that a function really returns one thing. Like functions, methods return one thing. Not so true in Python, but sort of true in Python. In Python, you can return multiple things. Does anybody recall where we may have seen a function that returns multiple things? I just showed you one example, actually. Remember, just like that. For k comma b in dict.items, right? That's two different things, right? One's a key, one's a value. We've also seen it here. Remember enumerate, right? What did enumerate do? When I had a list and I want to iterate over it and get for free the index or where I was, I could say for iteration comma item in enumerate, right? So I said it's multiple things. Under the covers, it's really only one thing. More precisely, it's returning you back a tuple. It's a concept called unboxing. And you see it quite a bit in Python. You don't see it in a lot of other languages. But it is kind of a useful feature here. And notice this is a tuple. I don't have to do something like, x square bracket 0, x square bracket 1, the way I would typically pull something out of a tuple. So again, we all should be familiar with this. When I enumerate a list and iterate over it, it's indexed from 0, 1, 2, all the way to the end, and the value that's in that list at that index. Just mention this when we saw this in dictionaries. When I have a dictionary, key 1, value 1, key 2, value 2, and so forth, I can say for key comma value. Again, if it helps you understand it a little better, you can just put the parentheses around it. Like, oh yeah, that's a tuple. Okay. This will be a quick little demonstration, but let's take a look at it. So write a function that takes a list of numbers and returns the min, max, and the average. Okay. So I'm going to create a function. I'll call it describe. And I'm going to say describe is going to take a list. I'll call it my list. And if I want my min equals the min function, pass it my list. My max, I can pass it my list. And then notice I've imported this statistics package up here, so I could use the mean function. Now I can say my mean equals mean or average of my list. Okay. So now, and let's return something here. Instead of printing it out, I can return my min, my max, and my mean. What does that look like when I call this function? Well, let's first create a list. My list. Let's put 1, 2, 3, 4 in my list. And let's call my function, describe. Pass in that list. And let's see what we get out. I gave myself some sample code there already. So I called my function describe, and I passed in a list which had the values 1, 2, 3, and 4. Inside here, I did 3 calculations, min, max, and mean. So I should get 3 things back. And so notice here, I got back when I print out output. What is that data structure? What data structure is wrapped in parentheses? Dictionary is wrapped in squigglies. Set is also wrapped in squigglies. Tuple. Tuple. So round brackets is a tuple. So notice it came back one big tuple, right? But I can do this unboxing, unpacking thing. I can say A, B, C, right? Because I know I get 3 things back. Now I can print out A, comma, B, comma, C. So notice right now it looks like a tuple. But if I catch my return like this, that unboxing thing happens, or unpacking thing happens, and it just simply prints out those things outside the concept of that tuple. Right? I don't like this. I don't like this at all. Part of the reason is it's very difficult to know what ABC is in this context. Which one's the max? Which one's the min? Which one's the mean? You might know because you wrote this function. But if this function was squirreled away in some module and somebody like me didn't give you a doc string, you have no idea if the first parameter is min, max, mean, whatever, right? Unless somehow they use the name tuple. But suffice it to say here, with a regular old tuple, I have no clue what A, B, and C is. So appreciate that this concept exists. Appreciate that that's the magic, the way enumerate works and the way items on a dictionary work. But you don't see it a lot in other languages. Okay, on to the concept of scope. This is one of these topics that if you are hardcore computer science, if you want to get into the theory, this is the stuff you need to know. This is how programming languages work. The concept of scope is vastly different in different languages. It is very, very important. If you're tending more into the cybersecurity side of the space, depending on what you'd be doing, this stuff might or might not be so relevant, because it would be very useful as a cybersecurity analyst if you were like securing or you're evaluating the risk of using a new programming language, right? Maybe you've seen in the news, my friends who are into cyber, that there's a lot of requirements for companies and agencies to use type-safe languages and memory-safe languages. That's where all this stuff sort of comes in. So this is why you'll find certain agencies will say, yep, sorry, you can't use C++, can't use C. Even though it's very efficient, it's not really memory safe in a lot of cases. All right, so what do we mean by scope? And we will look at a couple coding examples. But this structure shouldn't seem too foreign right now. I have a function called make zombies that takes a parameter called num. And it does some calculations, it prints out some message, and it returns a number of zombies. Obviously, when the interpreter sees that, it just squirrels it away in memory, it doesn't do anything. Here's my global scope. Here's the stuff that's happening outside my function. I declare a variable called human. I call that function here, passing in the value 10, print out some message, take what I got as a result from that function, and off I go. I used this word just now. There's really 3 scopes. This is one of these things you have to remember. This is kind of like definition time. One of the few things I'll sort of say, you got to know this is definition. This is global. These are global variables. This is the global scope. Basically, anything that's not inside a function is considered the global scope. Imagine it's like your program just thinks this is the entire world. My entire world is made up of these functions and these parameters and these variables and these statements. It's everything. That's the global scope. So when we look at this, how many global variables do we see here? And it's really a trick question. How many variables do you see here? I count 2, human and result. Everything else is just an expression. Inside a function is called the local scope. Every function has its own local scope. So what exists inside this function doesn't necessarily live inside another function. So again, if I'm the interpreter, right, that's executing this code, when I go inside here, I say, ooh, I am now aware of different variables. Variables that outside here I wasn't aware of. Imagine it's like you're outside your house. You can see things outside your house, but you can't see things inside your house. You don't know if you have pots and pans in your house. You don't know if you have a toothbrush in your house. Outside, you know if you have a car in the driveway. You know if you have a tree in the yard. But when you go into the house, which is equivalent of going into a function, you can look out the window and you can still see a tree. You can still see a car. You can also see your toothbrush. You can also see your pots and pans, right? So how many local variables do we see here? Two. Cool. Slight little bit of a trick. There's actually 3. It's just a little bit of a subtlety. I assume you saw human. I assume you saw zombies. Don't forget about the parameter. The parameters also constitute a variable, right? They don't exist out here. They sort of exist out here because you pass them in. But here, the argument is 10. The parameter is num. Num, if you tried to use the word num out here in the global scope, you get an error. It's not going to work. Like, you don't know, that's something that lives inside your house. That's your toothbrush. Your toothbrush doesn't live outside the house. Because scopes are distinct from each other, you can have the same variables, the same names in your global scope and in your local scope. But they have different values. And we'll see in a minute using Python Tutor, it lives in different places in memory. So out here on line 8, variable human has the value 1. As my code executes and I go into the make zombies function, notice I have a variable human. In this particular case, human has the value 10. Why? Because I passed 10 in as an argument to the variable num, or to the parameter num, and then assigned it to human. When I exit this function, human will be what I left with. It will be 1. It doesn't assume what happened in here. What happens inside the house stays inside the house. What happens inside the function stays inside the function, unless I return it. So let's run over and take a look at this. So this is that same function we were just looking at. So here's this def make zombies. When my code starts executing, the interpreter just says make zombies, just put that in memory. Just hold on to it as an object. It's an object in memory. Okay, in my global frame, synonym for scope, for whatever, notice human 1 comes into existence. That variable, that memory is allocated, and it lives there. Now on line 9, I'm about to go into my function. Notice there's a different frame or a different scope. When I go in here, notice that human variable exists. So I have a human variable out here in the global frame or the global scope. It has the value 1. And this local scope for make zombies, the name of my function, has the value 10. You can see when I print it out, humans inside this function has the value 10. Now when I step out of my code, notice here, this code is going to attempt to use the zombies variable. Look at the level of indentation. You don't see the word zombies anywhere. Therefore, it's not in scope. Here's my global scope. Here's my frame. There's nothing here that says zombies, even though it was in scope a minute ago, right? If I go back to when I was inside that function, sure, zombies existed here. But it's almost like you packed a suitcase, but you left it in your house. You didn't leave it, you didn't bring it outside the house. So now I'm outside the house. I don't have my suitcase. I don't have that zombies variable, right? So I get an exception. Zombies not defined. You've been using something called the built-in scope since day 1. The built-in scope is where things like global functions, for lack of a better word, I guess that's a bad word, global, but things like int are declared, string, len, enumerate, right? All these functions exist out here in what's called the built-in scope. It just is, it's just there. When your code is running, when the interpreter is running, it's first going to say, okay, I'm inside a function, I'm inside a local scope. What exists here? What variables exist? What functions exist? There's actually a function you can call called local. It will return you a dictionary. It will tell you every function, every variable that exists at that point in time. That is very, very useful when you're debugging. You'll probably need to use this when you're debugging your codes for the assignment, maybe. If you don't know why zombies doesn't exist, you can call this function. It will print out to the screen a dictionary of everything that's in scope. So, I have two functions, A and B. I have a variable called animal, declared at the global level, defined here locally inside A, and defined locally here inside B. They all have different values. And I'm just going to run through this code because this does the same thing, but so here's my function B. The global frame, the global scope is aware of that function, but nothing inside of it. The global frame is aware of that function called A, doesn't execute, doesn't do anything. Here, I'm going to say animal, rabbit. Okay, global frame now has the variable animal with the value rabbit. I'm going to call the function A. When I go in A, this local frame, the interpreter is going to say, okay, well, somebody wants me to print out the variable animal. You may be saying to yourself, well, it doesn't exist here. I've commented out on that. Well, the local scope says, well, I don't find it in the local scope. I'm going to go look in the global scope. And if it's there, and it is, it's going to use it. So inside A is also rabbit. Same story for B. I have a function that's calling a function. When I go in here, it's also going to print out rabbit. It's getting it from that global frame. Now, if I go ahead and now create a different variable inside these different scopes, watch what happens now. So now in the global frame, the variable animal exists. It has the value rabbit. When I go inside the local scope A, I'm redefining it. I'm reusing animal, but only inside my scope. So this still exists out in the global frame, but inside this local frame, it now has the value tiger. So when I print it out, it says this is tiger. When I go inside this local scope, so again, notice there's a global frame, there's the local scope for A, and there's the local scope for B. They all have the variable animal with different values. I can print this stuff out. So when I leave and I finally come back to the main flow of execution, the value in my scope, in my global scope, was preserved. Nothing that happened inside the house or inside this function here affected that. Okay, so as I mentioned, these functions, locals and globals, they just return you a dictionary. You can print out that dictionary. You can iterate over that dictionary, right? You can look and see, it's kind of hard to see here, but you can see, you know, I create a function called get new sport. New sport. The function is something that exists in this scope, and so forth. Okay, the last topic, I think, is doc strings. So as a reminder, comments. We learned how to do comments three ways. We could use the hash symbol, and then write the string. We can put that hash symbol at the end of our expressions. We could use single quotes, we could use double quotes, right? So here I have a single quote. And then here we have the multi-line quotes, right? That's typically what we've been doing in most of our programs. Going forward, even though it's nice to have a header in your file, like a header description, you're probably not going to see too many points deducted for stuff like that. Now, we're going to want to see you do this docstring thing. What is the docstring thing? Well, inside, let me just get this on the same line here. When you declare a function, right after def squared, we saw this in the slide I keep showing over and over again with functions. The first comment is the docstring. That's where you want to say what your function does. So square n, presumably squares a number, takes in a number, returns the square of it. Your function, as I mentioned, is an object, just like your variables are an object. This is kind of a hard concept for a lot of people to grasp who are used to other languages. In other languages, functions aren't necessarily objects, but in Python they are. So since square is an object, this object lives in the global scope, that object has a field on it, a variable called underscore underscore doc underscore underscore. We saw that similar thing in the last lab. You saw underscore underscore main underscore underscore, right? That's sort of your signal that something internal to Python is happening. So when I create my docstring and I say print square dot underscore underscore doc, I will get whatever that message was here. There's also a new function here called help. You can pass in any function. You could say help len. You could say help enumerate. You could say help str. You can say help int. You can say help whatever function you create. And that's going to print out a little nicer formatted string for you. This is typically what you see. Typically what you see is the 3 single quotes, and you see the information structured like this. Probably only in your projects will I require you to be that fastidious. But anybody who started assignment 7, I put in some examples, right? So for each one of the functions I asked you to write, I said, hey, this is a pretty good looking docstring. Let's not panic and over-index on this. I'm not going to expect you to write that much stuff, but I need you to write something at least like that. Add binary, returns the sum of 2 decimal numbers in binary digits. That's what I'm looking for. If you want to do all that stuff, it's a good practice to get into. How do you know what to put in here? It's been a while since I mentioned this, but remember this thing called pip8. Pip8 is this style guide for Python. It's not required, but if you want to hang out with other professional programmers, they're probably going to require that your code kind of looks like this. Has anybody ever heard of lint or linting? So in a lot of programming languages, lint is a method for, I guess the way you can think of it is like cleaning stuff up, right? If you have like a piece of lint on your clothes, use like a roller to get it off. Linting your code says, I'm going to look at your code and sort of make suggestions of how it can look better. So we want to put comments in the right place. We want to have, you know, when we have lines that wrap, we want them to do certain things. So inside the pip8 guidelines, you will see guidance on how to do comments, on how to do docstrings and things like that. So I won't go nuclear on that for grading, but yeah, just be aware that it exists. Okay, I mean, not much to see here. Here's a function called what something craves. I have a variable or a parameter A with the default plants and a variable B called Brondo. Anybody know where that's from? I thought you would know. Idiocracy, another great movie. I should get some clips from it. It's actually happening right now. It's insane. But suffice to say, I wrote a function. I have a doc string. I run help. I get a nice, pretty message here. Okay. From my perspective, we're done with chapter 7. So the offer's on the table tomorrow during lab. Again, I will not be taking attendance. It's completely optional. I will be in the 8 o'clock lab though, the 10 and the 4. If you want to swing by, we can work on homework 7 and assignment 7, so you don't have to worry about it over break. We can get that well out of the way before it's due next Thursday. If you didn't complete lab 7, if you show up in your assigned lab, I will open it up for you and you can take it. If you're in that 10 o'clock class, just send me an email and I'll open it up for you as an individual. On Friday, we move on to files. We will probably cover these sections here. All right? All right, folks, enjoy it.